Assalamualaikum warahmatullahi wabarakatuh. Hopefully you can hear me fine. It's kind of echoing in this class. Now, today we have the final part of chapter 10 that we will be covering, inshallah. Bismillahirrahmanirrahim. Rabbi zidni ilma warzuqni fahma. Allahumma iftah lana hikmataka wa shrah lana min khazaini rahmatika ya arhamar rahimin. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Alright, so in today's session we will complete chapter 10, which is about moment of inertia, and we will do a bit of recap. We have covered two components: how to determine moment of inertia by integration and also by composite using parallel access theorem, and then we'll try some of the questions from previous exam paper, inshallah. Alright, so to recap, number one, we have covered moment of inertia, right? And then, okay, let's try to hopefully this one is better. So for integration, we have learned, you can see this one, Ix is integration of y squared dA. If you use, hopefully you still remember which element, this is based on this element right here. And for, which one? Okay, for Iy equal to integration of x squared dA, this is with respect to this element over there, right? And if we want to use for Ix, okay, which marker is better? Okay, all the markers are not good. Integration of dIx, this is with respect to this element, vertical element, or Iy, integration of dIy with respect to this element over there, right? And for, let me use a different color, maybe it's still black. And for parallel access theorem, we have Ix equal to Ix prime plus a dy squared, and Iy equal to Iy prime plus a dx squared, right? And Ix prime can be, if it's a rectangle b and h, so Ix prime will be 1 over 12 bh cubed. This is the most basic one. For other shapes, you have to refer to the table, right? Alright, so these are the, hopefully you can see that one. These are to recap the equations that we have, and we have covered some examples both for integration. We spent quite a lot of time there, and also for parallel access theorem. Right, so let us go to some examples that we have now. Okay, let's go to, this is final exam for last semester. So the question is basically like this. So we have meaning the shaded area inside here, where y to 1 over 8 x cubed, okay, and this is 8 over here. This is 4 over here, x, y, and we need to determine the moment of inertia about y-axis. Alright, so the question just ask for this one. Right, this is exact question from last semester. Right, meaning the question actually asks what is the centroid of this area, and then what is Iy for this one. Right, so we'll just answer this one. Of course, we don't have the time. I will not go through the exact solution of the mathematical solution until the end. Hopefully you can try that one. I'll just show the steps, and hopefully you can go from there on. Alright, so first thing first, you have to select which element, right? So Iy will have either this element or this element over here, and the question says clearly specify which element used. So in the exam, you have to clearly specify whether you use horizontal or vertical. by drawing or writing it up, right? So in this case, the easier one is by using this one, obviously, like the normal equation, and it will be just something like this, right? So if you take it out, this will be dx, this will be y, which means dA will be y dx. Alright, so if we use this one, and the equation is this one, of course, so I y will be integration of x squared, and then dA will be this one, y dx. Obviously, we have to change y to x, so we get integration of x squared 1/8 x cubed dx, meaning integration of 1/8 x to the power 5 dx. Now, what is the limit? Right? So, hope you understand when we do this element, when we chop like that, and then the first element is here, meaning 0, the last element here will mean 4. Right? So, from 0 to 4, 1/8 x to the power 5 dx. So, if we integrate this one, we take this out, so we get x to the power 6/6, right? From 0 to 4. Meaning 1/8 times 6 is 48. Then you have 4 to the power 6, and then you can have something. This is in meter or something. So if it's unit in meters, so you have whatever value there, meter to the power 4, or whatever unit to the power 4. Right? So it's quite straightforward if you know what to do. Right? Straightforward. Alright, so there's no reason, in this case, there's no reason to use this element, right? It makes life harder and there's no reason for it. This one is straightforward. So if you get this one correct, you get the full mark for this question in the final, right? This is the previous year final. And then there's another, alright. Okay, so hopefully that is clear. So we'll go to another question where we have to determine moment of inertia of a differential. So hopefully this is clear, right? So I grab it off and we'll go to the next question. This is another question from semester 1 2017-2018. So the area is basically like this. And then we have y squared equals x, x here, and then y equals 1/8 y 1/8 x squared, and then this one is 4, this one is 2, x-axis, of course the shaded area is inside. So determine this specific question asks what is I x. It says determine the moment of inertia about x-axis of the shaded area, clearly specify the element used. Alright. So in this case, not obviously, but after you have done some exercises, you know that the easy one is the normal equation there, right? Meaning what? Meaning the element will be the horizontal element, right? If I take that horizontal element there, this will be dy. What is this length? Alright, so if I label this, because it's like this, I label this line 2, line 1. So it will be x2 minus x1, right? Where x2 is, if we shuffle this one, x squared equal to 8y, x equal to 8 power of half, y power of half. This is x2, line 2. This one is y x equal to y squared. So if you change this one, it becomes this one 8 power of half x power of half x not x y squared y power of half, meaning square root of these two and the square root of 2 minus y squared, right? So meaning that dA is 8 power of half y power of half minus y squared dy. Alright, hopefully that is clear. Right, so it's basically just x2 minus x1, but we have to transform x2 and x1 into of y. So we'll just use this equation and that equation. And I have mentioned in the class why I do like this a power of half y power of half instead of just like something like that, right? Because this, if you do like this, you tend to make mistake in the exam when you separate it, and it's not clear. Both have the power of half, right? Both have the square root. Alright, so applying this equation over here, so Ix will be integration of y squared dA, which means this one, 8 half y half minus y squared dy, right? And then expand this, we'll get integration of 8 of half y 5 over 2, right? Or 5 over 2 minus y over 4 dy. What will be the limit? When you do like this, meaning you chop off like this. So the first element here, the last element here, meaning from 0 to 2. 0 to 2. Right. So it's just integrate. So 8 power of half y power of 7 over 2, meaning 2 over 7 here, minus y power of 5 over 5 from 0 to 2. Right. And then you just plug in the values, so you get like that. And then 2 over 7. And then there's 2 power of 7 over 2 minus 2 power of 5 over 5. And then you get your answer in terms of meter to the power of 4. Right? Whatever meter to the power of 4. As you can see, you can actually solve this kind of question quite easily and quite straightforward and in a short time, actually, as long as you know what's going on and what to do. Right? Avoid making mistakes in terms of selection of element, make sure you remember the equation and know how to do this one, and it's straightforward. Right? So chapter 9 and chapter 10 should be full mark for you in the minimum of time. And most probably it should be the first question that you start, probably, because you should save time here and just settle them, right? So that's the question in this exam paper. And then, but there's a part B then. Part B says determine the moment of inertia Ix of shaded area, but not this one, it is a composite. So I'll draw that one for another one. So sometimes the exam will be based on whatever the lecturer decided in that semester. Sometimes they ask both. Like in the previous semester just now, moment of inertia is just integration, but for this semester I'm looking at right now, it asks both integration and also parallel axis theorem. So we'll try that one right now. Alright, so the question is basically like this. So you'll have 150 mm here, 150 mm here, 100 mm here, 100 mm here, 150 mm here, and then this one is 75 mm. Alright, and the question says determine the moment of inertia about y-axis. Alright, so the question asks what is I, y. Alright, so first understand the question. It asks question, okay, this is x-axis, y-axis. So the question asks what is the moment of inertia about y-axis of this region, right? Meaning this is the region where this is the hole. So as we mentioned before, the first step is for you to, first you have to understand the question, and you know you will be using this equation over here. And the moment of inertia of the whole area is a combination of moment of inertia of each area, right? So we can divide into 3 segments. So let me label this one. Okay, so we will have this rectangular triangle and circle here, right? So in that case, so we have okay, let me go here. So we have this one, right, where we have this is 200. Okay, my code is not to scale, but right, meaning it's 200 and this is 300, and right, obviously this is longer, but just bear with me, understand the concept, right? So this is the rectangle we're considering, and then plus the triangle. Okay, sorry. Like I mentioned in the class, it's best to draw the axis straight away so that you avoid any mistake. So in this case, the axis is what? The axis is here. Y-axis. Correct? Right. So it's there. For the triangle, the axis is there and the triangle is somewhere at a distance. Like that. Right? And then you have 150 here. Hopefully you can see the red color. Hopefully you can. And the 300 here. Right? And then this is the y-axis. And then plus, oh no, sorry, minus, because this is a whole, so minus the whole there. Where the axis is also at a distance here. Right? And this is like alright, this one is 75 millimeter, right? This one is also 75 millimeter. The radius is 75 millimeter. Alright. So based on this equation, hopefully you still remember, this is based on the IY at the centroid, right? So we need to know where is Y prime. So in this case, this is the centroid and this is the Y prime. Right. In this case, this is the centroid where it's 1/3 2/3 ratio, right? This is 1/3 and 2/3. So meaning what? Meaning this is 50 millimeter, right? And this is 100 millimeter, right? And this one, okay, this is Y prime, and then this is Y prime. Why do we need this? Because we need to find what is dx. Right? Meaning the distance between the two axes. In this case, it will be 100 millimeter. In this case, this distance will be, what is this distance? This is 200 plus 50, meaning this is 300 millimeter. Right? 200 plus 50. You get 300. And this one basically is, okay, this is the center, so it's basically 100. Right? This distance is 100 millimeter to the Y prime. Alright, so based on that, we just apply this one straight away. So IY is basically just IY prime plus A dx squared. And IY prime is 1/12 HB cubed. Right? Just like this one, 1/12 DH cubed, this one 1/12 HB cubed. Okay, sorry. This one is for what? For rectangle. And now you have triangle and round shape. So in this one, I scroll down. So in the question paper, if you have shape like this, as I mentioned, they will give you the table. And you have to know how to look at the table. So please try and look at the table and see whether you get this value. This one also in the table, of course. If you look at the table, you will have 1/12 HB cubed. And for the triangle angular, for the triangle area, so it gives there one Ix is 1/36 BH cubed, right? They will give you for triangle Ix equal to 1/36 BH cubed, right? And it only gives you that one. It doesn't show in the table. Please look at it and see if you understand. It only gives you Ix. Okay, in this rectangle, you will see Ix and Iy. Ix will give you 1/12 BH cubed, for Iy 1/12 HB cubed. But for triangle, it only gives you Ix 1/36 BH cubed and no Iy is given because the way the triangle is drawn. So you have to understand if Iy is just 90 degrees of this one or 1/36 HB cubed, right? And for circular area, the table will give you 1 over 4 Iy is 1 over 4 pi r power 4, pi r power 4, and it's the same because it's circle, so 1 over 4 pi r power 4 for ix and also iy. Alright, so make sure you get this value from the table. Do not trust me, see for yourself in the table, make sure you know where to get this one, because in the exam you have to actually know yourself where to get this one before now and see whether you can get this value from the table. Alright, now, so we will use this in this here, right? So, Iy prime for this one is 1 over 12, then you have 300, and then you have 200 cube, right? This one is 300, this one is 200 for this shape here, right? And then plus area is basically just 300 plus 200, and dx squared. Dx is 100 here, so 100 squared. Alright, are you following? Hopefully you are. So this is Iy prime, this is a dx squared. Right, we are using this one. Alright, what about this one? So plus, you know this one, this equation, right? So this is for Iy prime, you have 1 over 36, then you have this one 300, and then this one 150 to the power of 3, 1 over 36, that one and that one power of 3, right? Plus area, what is the area? Half times 300 times 150, and then the x square is, the x is 300, right? So 300 square. Alright, hopefully you are still following. So this is Iy prime, this is the A area times dx square. This one, remember this is minus, so we will minus this whole thing. Right? We will minus the whole thing. So Iy prime is this one, so 1 over 4 pi r4, so r is 75, so 75 to the power of 4, right? 1 over 4 pi r to the power 4, and then plus, so inside here plus, but we will have the minus there after that, right? A area is pi r square, so pi 75 square times dx square, which means 100 square. Right? So that's how you do it. Right? Make sure it is very structured and you can follow, and then just add them up together so you get whatever value there. In this case, millimeter, right? Millimeter to the power of 4. Alright. Now, in this case, I know some of you like to convert into meter, for example, then you have 0.3, 0.2, etc. If you want to do that, make sure you do it properly and correctly, because when you have 0.2 to the power of 3, then you have many decimal points, right? So it might be confusing and tedious. I like it when you do it in millimeter. Of course, if you do it in millimeter, you'll have a big number with many zeros. If you do it in meter, you get 0.00 something, for example, right? I don't have the answer script here. You can try, right? So this is just to show how the steps is, and as you can see, it's straightforward. It should be short in time, and you should not do any mistake here, hopefully, inshallah. So this is the question for semester 1, 2017 and 2018. So hopefully that is okay, right? Meaning you can see that the question is not difficult, right? For chapter 9 and chapter 10. We are covering chapter 10. Hopefully chapter 9 will be somewhat later. We'll do revision on previous exam also. Alright, so we'll take a look at one more maybe exam paper. This is semester 2, 2017 and 18. Okay, we have some integration there. Now, what will be changing is just the shape, right? The step will be exactly the same as we can show here just right after this, right? So it says here, so we'll have, this is 8 meter, this one is 4 meter, this is y equal to 1 over 8 x cubed. Have we done this one before? No, right? So this is shaded area, right? In this case it says determine moment of inertia about x-axis. So Rx. Alright. Okay, so let us use let me see. Let us use horizontal element, right? Because for vertical element, I think the step will be exactly as before. Okay, let's say this is just the steps and you can try yourself. If you just use, horizontal element is no, what am I saying? We want to find Ix, is it? Okay, so in this case, if you use Ix, horizontal element, that will be easy, right? Never mind, we'll just do this is very easy. So it will be something like this. So this will be d1, this will be x for this particular element, right? So meaning dA is dy. So for whatever reason, the question of moment of inertia of the past exam is always easy. There's no 1 minus something, except for that area just now, right? So it depends. The level of difficulty tend to change depend on what the lecturer decide. Sometimes depend on how the performance of the midterm. So if the midterm, for example, this question is very easy, perhaps the midterm at that time is very, very low, so it makes it easy, perhaps. So do not expect for your time the question will be easy. Just be prepared for the worst, and hopefully you can answer anything that comes. Anyway, so this is the case, and with this we just apply this one, right? So Ix is integration of y squared dA. dA is x dy. Now, for the exam, I skip this step, right? Because I have written it there. But for you, it's best that you write x integration of y squared dA. Because normally this will give you some marks already. If you skip, you will miss that mark. Normally. Anyway, so in this case, x equal to, so this equation we have seen before. Right? Have we covered this one before or not? Or is it deja vu or something? Because okay, let me see. Because here x, no, it's different, right? It's x cubed. Alright. So, x cubed is 8y. So x is 8 1 over 3, y 1 over 3. Because in the previous example, we may rewind. I think it's square here, right? So 1 over 2, 1 over 2. It's somewhat similar, but it's different. Anyway, so you have this equation here, meaning y squared times this one become 8 1 over 3, y 6 7, is it? 7 over 3 dy. Is that correct? So y squared and y 1 over 3. So 2 becomes 6 over 3, 7 over 3. Alright. And the limit will be what? If you chop like this, so it will be like this. So the first one and the last one there, right? So from 0 to 8. Alright. And then it's just integration. So 8, 1 over 3. So we'll have here y 7, 10 over 3, right? 3 over 10 from 0 to 8. Correct? Hopefully it's right. Okay. I just do this spontaneously. I don't have any answer scheme or whatever. Hopefully I don't have any mistake. Please do check. Because if you know, right, in the class sometimes I do some little mistakes. So make sure you check. Hopefully there's no mistake here. Alright. So in this case we have 8 1 over 3, and then 3 over 10, and then 8 over 10 over 3. And then you can calculate whatever is meter of 4. It is meter. Right? So as you can see, all the questions are quite straightforward. It doesn't take that much time to solve. for chapter 10 so far, right? Chapter 9 is similar also. Okay. Now in this particular exam in semester 2 2018 17 and 18, they have one part here and another part moment of inertia composite. I think that's the reason why the question is very easy and short, because they want to ask both part, meaning for moment of inertia they ask integration and also composite, right? In some exam like before, where you have the a bit more difficult integration question, you only have one component, I think, right? So that's the possibility. All right. So we'll go to the composite part of this question. The question is basically like this. You have this shape. This is x, y, and then we have. So it's basically the combination of three basic shapes, just like before, just that the placement is different. So here you have 300 mm. Here you have 200 mm. Here you have 150 mm. And then the height there 100 mm, 100 mm, and the radius is 75 mm. So this is exactly the same dimension wise, very similar or almost the same. It's just that if you remember before, it's flipped in that way, right? The triangle is there. All right. So we need to find what is moment of inertia but y. So I have y into 1. Now, if you notice, so far the exam question that I have covered so far from the previous semester, for composite they like to ask IY if they only ask one. Sometimes they ask both IX and IY. But in this question, or maybe because in the class we always try IX, right? So they want to see out IY if you can do it, right? Alright, anyway, so what we do is again define the shape. So basically we have rectangle, triangle, rectangle minus the circle, right? Okay, so basically we have this triangle. Okay, this is the triangle. Where is the axis? Because it is with respect to y, so this is y-axis, right? And the shape is, this is 300 mm and this is 200, right? 100 plus 100. Okay, plus, and then you have y-axis here, and at a distance you have the rectangle. Okay, this one is quite interesting. This one is what? 350, and this one is 200. Okay, and then minus, we have y-axis here, and then you have circle there, where the radius is 75 mm. Alright, and let's define because we will, again, the equation is Iy equal to Iy prime plus A dx squared, right? This is the moment of inertia of y-axis of the on the centroid of the area. This is the area of the shape. This is the distance between the two axes, right? So y prime is here, right? Meaning this is 200. Meaning this is 200. This is 100. Like 1/3 ratio on that side. This is at the middle, y prime. So what is the distance? The total distance here. So it is basically this 300 plus half of this. So 300 plus, what will be half of this? 175, right? 300 plus 175 means 475 millimeters. Correct? Hopefully I'm correct. Okay, do not make a mistake. Do not add 300 and 200 because this is not at the center, right? This is the center of the circle. the center of the rectangle is half of this 350, which is 175 plus 300 becomes 475. Alright, and then this one, the x is basically just this one, 500, right? Right, until this center here. Right, so that's number one. Make sure you draw that. There's no mark here in the because it's not compulsory to draw, but it will be very helpful for you and for the examiner also to follow what's going on. Alright. So simply IY is addition of individual IY. Right. So in this case, so IY prime 1/12. Hopefully you already. Okay, sorry, not 1/12. Sorry, I made a mistake. This is not a rectangle. This is a triangle. So meaning 1/36 BH cubed for IX. For IY is just 1/36 is B cubed, right? So IY, so here 1/36. So 200 here, and then this 300 becomes 300 cubed, right? From this 1/36 HB cubed, right? So this one and then this one cubed. Plus area is half times 200 times 300, and then times. Okay, I didn't draw it. So this is right. So this is what 200. So 200 square for this one, for the x square. Okay, so this one 1/12. So 200 350 cubed, right? Plus 200 350 times this one square, 475 square, right? And then we have to minus all of this, and it is IY prime is 1/4 pi out of 4, so 1/4 pi 75 over 4 inside plus, and of course outside it become minus. A, which means pi r square pi 75 square, and then dx square, which is 500 square. Hopefully you can see, right? You can zoom in. Hopefully you put it in big screen with this video so that you can see the numbers. And then you just add them out, add minus minus, you get whatever millimeter power 4. Right? Okay, just because someone actually just consult me in terms of the changing of unit, hopefully you know that 1 meter is 1000 millimeter, right? So if you want to change, okay, but 1 meter square, how many millimeter? It should be 1000 square millimeter square, right? It's not 1 meter square equal to 1000 meter square, millimeter square. It's actually it becomes 1 million millimeter square, something like that. If you have power 4, you have power 4, etc. Right? So make sure you don't make any mistake in terms of conversion of unit. For example, here, if you see, anyway, hopefully you get the unit there. Okay, so and again in this particular exam paper, in this particular semester, because they give you this shape, for this one you are given actually in the question paper the table for you to refer. We do not expect you to remember this one, but you can. It's not that difficult, but maybe it's extra burden and it's not fair to penalize someone who do not remember this one. But this one because we do this a lot, and yeah, 1/12 BH cube. You should that should be inside your brain already. Yeah? All right. So is there anything else? Okay. We have 2 more questions. Right. This is semester 3 2017-2018. Alright, so quickly, I think you get the idea and you already understand, because it's a repetition of the same steps for different shape, right? So let's take a look at this one shortly. So we have shape like this is the area, and then we have 1 meter here, 1 meter here, so this is quite easy. So this is y cube equal to x squared. And the question actually asks, calculate Ix and also Iy. So in this semester, the question actually asks for both Ix and Iy. Right. So I think you got the whole of this already. So I'll just answer for Ix, right? Just to see. Because for Ix, if you use I go for Iy. Sorry, because Ix this will be this element, right? And it will be very easy. So let's go for Iy. Right? For example. So if you have Iy into integration of x squared dA, meaning the element will be vertical. Right? So the element will be like this. Right, meaning this is dx. What will be this height? 1 minus y. So dA will be 1 minus y dx. Right, this is 1 minus y. And y is what? So from here, y is x power of 2 over 3. So meaning dA is 1 minus x power of 2 over 3 dx. So plug in here, so what you get is integration of x squared 1 minus x 2 over 3 dx, which means integration of x squared minus x 8 over 2 dx, right? And then what's the limit? Of course, in this case, you chop it like this, so it's from 0 to 1. So when you integrate, it's simply just x cubed over 3 minus x 10 over 2 comes to 10, 0 to 1, and then you can plug in, you can solve, right? Alright, that's one way to do it. Another way, if you are asked to use horizontal for Iy, right? So let's try this one, right? So if you need to use horizontal for Iy, so if you use horizontal for Iy, so Iy becomes integration of diy. And what is diy? So you have shape of y-axis and this, right? Where this is dy, this will be x. Correct. And based on parallel access theorem, we have shown this in class, where if for this x and like this, b and h, it becomes ix become 1 over 3 bh cubed. Right? So similarly, if you have something like this is y. Let's say this is b and h, so you get iy equal to 1 over 3 hb cubed. Right? So in this case, diy will be what? 1 over 3 x cubed dy. Right. Originally it's basically 1 over 3 dy x cubed, but it will become something like that. If you do this, of course, from here to here, from 0 to 1, and then if you integrate, you will get x power 4, so 1 over 12 from 0 to 1. Now, if you plug in and you plug in the previous one, it should give you the same answer. And you can try. If you guys are different, then we can refer to the next class, but it should be the same unless I did some mistakes. It should be the same. Right, so yeah, and okay, and the last question, another question about composite. So I'll just show you, just to show what is possible to come in the exam. It basically is you go the cross section, something like this. Something like that, where, okay, this is quite confusing. This one is 30, this one is 170, this is all in millimeter, this is 30, this one is 140, this one is 30, this one is 30, this one is 70. Alright, this is the shape area. Right. And the question asks, determine the moment of inertia about y-axis, IY. Right. So you need to find IY. Of course, in this case, it's basically combination of rectangle. Right. So it's up to you how you want to divide the area. One possibility, you do like this, meaning 1, 2, 3, right? So in that case, if I do it like that, so the shape that I have, because it's about y-axis, right? So you get something like this, y-axis, and then for the top one you have 30 and the whole thing is 100. Then plus, for this one is y, this one, then you have something like 30 here, and then 140 here, and then plus y-axis, and then 30 here, and 200. Right? So what you do is that is again, Iy is Iy prime plus ADX squared. So Iy in this case what? 1 over 12, 30, 100 cube plus 30 times 100. And okay, in this case y prime is at the middle here, right? Which means half, which means 50 squared. Right. And then in this case plus 1 over 12 times 140 times 30 cube plus 140 times 30, and then y prime is here, which is half of that, which is 15 squared. Half of that is 15. And then plus this one, 1 over 12, 30, 200 cube plus 30 times 200 times y prime is here is half, which means 100 squared. Alright, and then solve. So as you can see, it's quite straightforward and you don't need much time to solve a question like this. Now, another possibility is if you divide it, I use the black one, if you divide it like this, meaning 1, 2, and 3. Right? I don't prefer to divide like this, but the answer will be the same. Why I don't prefer? Because when you draw it, you will see it's quite different. It will be something like, for this whole here is shaped like this, where 30 and the whole thing is 140, 170, 200, right? It will be something like that. And for this one, it will have something like this. Correct? Where this is 70, this is 30. For another one, you have something like this, where that is 170 and 30. Now, it's not that it is difficult, it's not that the answer will be wrong, it's still okay. But like this, if you see, to get the dx is quite straightforward, half, and half. In this case, obviously this is half, but this one you have to add this and this. For this one you have to add this and this, right? So personally I would like to avoid mistakes, so I tend to divide in a shape that, in this case, everything is attached to y, so it's easier for calculation. Sometimes the question doesn't allow for that, but in this case it does. So, but if I try those, the answer should be the same. If it's different, then something is wrong with one of the calculation. Alright, so that's it for today. Hopefully you can follow all this this is the end of chapter 10. If anything not clear, please ask in the next class. Remember, in the next class you have 2 quizzes, one from chapter 9 which is composite, one is chapter 10 which is integration. So thank you very much if you watch until this point. If you're not, then it's okay, hopefully you can answer the question anyway. So thank you very much. We end this session here. Subhanakallahumma wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Assalamualaikum warahmatullahi wabarakatuh.